Common sense suggests that technology improves over time, with each new version of a product being superior to the last. Yet this is not always the case. Often adding one feature comes at the expense of other features. For example, take a look at your mobile phone. I'm guessing you'd all like a longer battery life, right? And this is something we could absolutely do, but at the cost of a thicker and heavier phone, which I'm guessing is something you probably don't want. So there is a necessary trade-off between size and battery life, which is due to the current limitations of battery technology. And as we'll see, something like this is already starting to occur when it comes to large language models like ChatGPT. Features added to the newest LLMs to improve accuracy for some use cases seem to be reducing performance for other tasks, suggesting LLMs may have underlying limitations we do not have the ability to fully overcome. This is actually one of the findings in Apple's recent viral research report, which pointed out how LLMs designed for reasoning struggle with rudimentary puzzle solving. And on the topic of Apple, it is notable that the one major tech company whose value proposition is creating reliable and easy-to-use products is also the only major tech company not fully embracing AI, which further suggests the technology may have real limits in the here and now, and that we need to deal with these limits, rather than just hoping that model improvements will get rid of them the day after tomorrow. So what are these limits? And how do they impact the ability of large language models to provide accurate and trustworthy facts? Hi, and welcome to Data on Stage. I'm Nick Quaass, and I've worked across a variety of roles here at Statista as a researcher, analyst, and more recently in sales enablement.
And I'm Vorobiev. I'm one of the solutions consultants for Statista Connect. So thank you for joining today's session. Now, this is the second webinar in our series on demystifying AI for knowledge work. While it's not necessary to have the previous webinar, today we will be building on many of the themes it covered. So don't go anywhere. But following today's webinar, I strongly urge those of you who haven't seen it to take a look, and we will provide a link in the chat. So, to what extent can we trust LLMs like ChatGPT, Gemini, and Claude to give us accurate information?
Well, I'm sure most of you have seen figures like this before, which show hallucination rates of just 1 or 2%. And I'm guessing that many people come away from this with the assumption that this means the models are right 98 or 99% of the time. But this conclusion is wrong. Very wrong, in fact. As per the saying popularized by Mark Twain, there are lies, damn lies, and statistics. Meaning we need to dig deeper than the headline numbers and figure out what these numbers actually show. And on closer inspection, what these figures really measure is how accurately each model summarizes a document it has been given, not how accurate the models are in general. Meaning the 1 or 2% is how many facts the model got wrong when summarizing a text which already contains those facts. So rather than a sign of high accuracy, these results are a bit more like a student cheating on a test and still getting a couple of questions wrong, even though the answers were right there in front of them. When we look at tests that only measure the accuracy of the model itself without access to external data, the results are much, much worse. Based on OpenAI's own testing, its standard O1 model is only right half the time and hallucinates the other half. And perhaps even more concerning is that OpenAI's more recent models hallucinate even more. To use our cheating students metaphor again, now they don't have the answers right in front of them, they're basically just guessing half the time. OpenAI states in the paper these figures are taken from that it doesn't actually know why the models have increased hallucinations and that further research is needed, which puts into serious doubt the assumption that model improvements will naturally solve the hallucination problem over time. In other words, hallucinations and inaccuracy are here to stay for now, so we need to figure out how we're going to deal with them. You might ask whether other models fare any better, and the answer is, well, no. Based on a test of 200 questions covering spatio-temporal reasoning, social intelligence, and a few trick questions for good measure, all current models are far behind the human baseline, with most models being wrong over half the time. For all their power, LLMs can still really struggle with the basics.
Of course, LLM providers know this and have tried to address this problem by integrating web search features into their LLM chat tools. This way, the model has access to external data, and it's not relying on its own internal resources. But as we saw in the last webinar, this is not sufficient to solve the problem. LLMs struggle to consistently select reliable, up-to-date, and accurate sources. And even when they do, they can still misrepresent the data from the source, meaning all facts and sources need to be manually verified. All of them. As even if only 10% is wrong, you don't know which 10% that actually is. In other words, LLMs are great for productivity, but terrible for truth. The temptation of just letting an AI do the research for you is understandably strong, but without robust verification, AI output is all but guaranteed to contain inaccuracies. And how can we know that others have not given into that temptation, letting these inaccuracies creep into their content? Putting all this together, we can sum up the impact of AI in just one word: uncertainty. Specifically, we can unpack three main layers of uncertainty for knowledge workers using AI. First is uncertainty over AI outputs. As we just saw, LLM output is inconsistent with alarmingly high rates of inaccuracy, and there is no guarantee this will change anytime soon. Second is uncertainty over the quality of online data itself. While disinformation was a concern before ChatGPT burst onto the scene in late 2022, AI has turbocharged this problem. Online content can now be generated quicker than anyone can keep up with, making it harder and harder to know which data to trust. Crucially, this need not be a result of bad faith actors. Disinformation can be inadvertently increased by those who simply give in to the temptation of efficiency and don't fully verify AI content before publishing it. AI is therefore very much a double-edged sword when it comes to research, as its efficiencies have created deeper and deeper pool of disinformation that researchers need to navigate. Now, while experienced researchers develop instincts to quickly identify questionable sources upon sight, AI models lack these instincts and can take clear cases of disinformation as fact, further adding to the problem. And to make matters even worse, many reputable sources, including Statista, are closing their doors to AI web searches, pushing AI models towards the murkier corners of the internet in a potential death spiral of disinformation. For all these problems, it remains the case that we must engage with AI so as not to be left behind, which is the third layer of uncertainty. Uncertainty over whether you are adopting AI the right way. So let's be honest. As knowledge workers, we are all scared that the person next door figures out how to fully leverage AI, and we will therefore outcompete us in today's hyper-competitive world. But there's no clear set of best practices on how to leverage AI yet. We are in the middle of this change, and all finding our way through together, experimenting to see how these tools can help with our specific needs. So, how do we navigate this uncertainty?
Well, let's take each in turn, starting with uncertainty over LLM outputs. One technique has established itself as the standard approach for increasing the factual accuracy of LLM output, which is retrieval augmented generation, or RAG. So while this does sound complex, RAG is actually an extremely simple concept. It simply means enhancing LLMs by feeding them external data at the point a query is run. So this data can be anything from internal reports to web pages to proprietary research. Also included with the data are instructions that force the LLM to base its answer just on this external information and not any data from its internal knowledge. In effect, RAG is therefore able to give LLMs information that is not included in their internal knowledge, like events that might have occurred after the model was trained, or private data the model could have never known. Based on our own internal benchmarking, RAG significantly increases the factuality and the relevance of LLM responses. Of the models tested here, only Perplexity Pro and Gemini have access to web pages, effectively making this a comparison of RAG versus non-RAG responses. And as you can see, both models produce more accurate and factual responses than models without access to external information. However, you can also see that hallucinations remain a problem. So why is this? Why do hallucination rates remain the same, even though factuality and relevance are increased? To answer this question, let's dig a bit deeper into how a RAG pipeline actually operates. There are 4 key elements to any RAG pipeline: the sources, how those sources are stored in a database, the data retrieval system, and the guardrails. And the quality of the overall system depends on how these elements are implemented. Let's start with the sources. In the case of Perplexity and Gemini, the sources are the entire corpus of online content, or at least those websites which allow LLMs to access them. And as we've already seen, there are increasing questions about the quality of online information. We'll talk about this in more detail later. For now, we can just note that these concerns may play a part with the issue of persistent hallucinations. Secondly is how the data is stored. In the case of an LLM with web search capabilities, there are potentially infinite ways the data can be stored, as that's up to individual web pages. This can affect the accuracy of the output, as some types of data are better suited than others to RAG. Moreover, there is a connection between data types that do not play well with LLMs and increased hallucinations, unless specific guardrails are in place. Third is the question of data retrieval. As covered in depth in our previous webinar, there are major concerns with AI's ability to select relevant, reliable, and up-to-date sources. Also, access to partial data from online sources, like when information is behind a paywall, is a known cause of hallucinations. An imperfect data retrieval system is therefore highly likely to add to hallucinations. And finally, we have the guardrails. This is effectively the prompts that tell the LLM to only use the external data when formulating its response, plus any additional instructions the engineers have found which improve the quality of the output. An example of the latter could be something like creating a template for the LLM's response to follow, or explicitly telling the LLM not to answer a question if insufficient information is available. In the case of an LLM which could process a potentially infinite number of questions about a potentially infinite number of data types and structures, it's extremely hard, if not impossible, to include specific guardrails, as the number of potential edge cases is limitless. An inability to include specific guardrails is therefore also a cause of hallucinations.
Now, in the next part of the webinar, we want to show you how we at Statista have overcome these issues in our AI research tool titled, Research AI. This is intended as an example of best practices, so please feel free to adopt these principles in your own AI systems and workflows. While naturally we are proud of our tool and would love for you to use them, the main aim of this webinar is to educate everyone on the risks of using LLMs for research and giving you some concrete strategies to mitigate these risks. Now, if you don't mind, I'll skip over the question of sources for now, as we want to focus on this in more depth shortly. For now, just let me note that we have a curated collection of data which eliminates the risk of unreliable sources. Instead, let's start with how the data is stored. Now, there are formats of data that work extremely well with AI and forms which cause more trouble. Notably, LLMs really struggle with long documents and large tables of data. And this is for two reasons. First, because the more information an LLM is given at once, the more the model's performance tends to decline. LLMs thrive on having short, concise chunks of text to process, which is why most RAG setups will chunk larger documents into smaller, chunks. The model then just needs to process the relevant part of the document, not the full thing, which makes sense. One does not need to read all of War and Peace if all one wants to know is who wrote it. But that leads to our second issue, that this process of chunking can lose context. To continue our example, now that we know Tolstoy is the author, let's say that we are doing a research project on him, so we break several biographies into small chunks and upload them. However, many chunks likely don't refer to Tolstoy as, Tolstoy, instead using a pronoun like he or him, and from that chunk alone, the model does not know who that pronoun refers to, leading to, inaccuracies. It may miss a crucial fact because it doesn't know who he is, or even report incorrect information by associating the wrong person to the pronoun. In other words, the model does not have sufficient context, which increases inaccuracy. This issue is especially pronounced with large tables of data, which often lack context altogether, especially if they have been chunked into smaller pieces. As anyone who has used LLMs for data analysis knows, getting it to work in even the most basic way is often a case-by-case process, involving lots of specific guardrails born from trial and error.
So we overcome this issue through formatting data in a way that makes it as accessible as possible, with our researchers selecting the most appropriate visual for that data series and then accompanying it with a short written context. And this has always been our approach to data, which is great because it turns out this combination of a limited set of figures plus a written context is exactly what AI systems thrive on. No breaking up of text mid-sentence or long data tables that lose meaning when chunked, just a short, self-contained overview of a particular fact, which can ground an LLM's output. Next is the issue of ensuring the right information is retrieved. Our engineers have leveraged our existing search capabilities to build a customized pipeline which analyzes the original query and then selects a range of relevant statistics based on this analysis. We're extremely fortunate in that we have the in-house expertise on this exact topic, which we could then leverage to build a custom retrieval pipeline. Because this is the level of attention needed. If the wrong information makes it to the LLM, you will get the wrong answer. The importance of building a proper data retrieval pipeline cannot be overstated. And finally, we have the guardrails. Because we know what the data types that will be included in our RAG pipeline are, and the use cases for the tool, we can put in specific guardrails for that data and use. For example, we've instructed Research AI to recognize when there is insufficient data on a topic and not generate a response. We've also put guardrails in place around how the response is to be structured, which greatly increases accuracy and, crucially, also transparency. And the results speak for themselves. Through this approach, we have been able to create a research tool with a significantly lower rate of hallucinations than other LLM tools. Research AI is 20% less likely to hallucinate than LLMs when answering the same questions, a number which will improve over time as we further refine our RAG pipeline. And as Research AI pairs our trusted data with cutting-edge LLMs, any improvements to the underlying models will also flow through to the tool. Research AI is also much more transparent than other tools, making it easier to verify any output. All data is clearly referenced with direct links to the original source, allowing for a much more efficient verification workflow. A well-implemented RAG system is therefore the most powerful tool we have to address the uncertainty of AI outputs. But it must be well implemented, because without proper attention to every element in the pipeline, results can still be unreliable. Even with a well-implemented RAG system, though, there is uncertainty over the quality of data sources. And as we've seen, there are some serious question marks over the quality of online information. And it's highly likely that increasing AI adoption will make these issues even worse. In more limited RAG systems, this isn't really a problem. For example, if you're just using your internal documents, or just using quality data on a single topic, maybe from another market research provider, this isn't an issue. But what happens if you need a broader range of data to provide accurate answers over a wide range of general questions? This is where our database of 1.1 million curated statistics from over 20,000 human-verified sources has a unique role to play in an AI-enabled world. Over the last 17 years, our mission has been to build up the broadest possible collection of relevant statistics from trusted sources, with each statistic hand-chosen by researchers who are an expert in their field. And we're lucky because the way we've formatted this data just happens to be perfect for LLMs. Our database is therefore an essential resource for the verification workflow of any researcher. Each source and fact has already been human verified, while Research AI provides a way that one can leverage the flexibility of AI with minimal risk and with a streamlined verification process.
Now, this talk of workflow brings us to the third layer of uncertainty, whether one is leveraging AI the right way. As mentioned, we are in the process of that AI transformation, meaning there's no correct way to implement AI. Best practices and optimal solutions are being worked out now through experimentation, which means everyone is at a different place when it comes to AI adoption. To cater for this new reality, our recent priority has been to increase the ways people can access our data, so that we can meet them where they are on their AI journey. every person has a different use case and tolerance for risk when it comes to AI adoption. For those understandably cautious of the technology, for example, in professions like healthcare or public policy, where one mistake can mean the difference between life and death, our traditional platform remains a trusted source of information amidst a landscape of increasing disinformation. And for those who want to leverage AI in the safest possible way, Research AI provides that exact opportunity. And Statista Connect is our answer to those seeking greater flexibility in how they use our curated data within their own AI workflows. While Research AI offers a streamlined interface with pre-configured prompts and retrieval settings, maximizing ease of use and minimizing hallucinations, Statista Connect moves in the opposite direction. It allows you to integrate our data directly into your own systems via an API. Now, what is an API, or an application programming interface? It allows one piece of software to request and receive specific data from another system in a structured, reliable way. Think of it like a restaurant. If your software is the customer and Statista's data is the food, then the API is the waiter. It takes the customer's order, delivers it to the kitchen, and returns with exactly the dish that was asked for. Now, what's the advantage here? Flexibility. You get to define the logic, select the model, manage the retrieval pipeline, and tailor the prompts, all according to your use case. You can blend Statista's verified facts with your own proprietary data and embed the results into dashboards, custom applications, or even a custom LLM chatbot. That being said, there is a trade-off. With freedom comes great responsibility. Statista Connect gives you control over how and when our data is accessed, but this also means you take on the engineering complexity of the implementation. Prompt tuning and output guardrails all fall on your side. And more importantly, with that freedom comes the need for stricter output verification, as we cannot constrain the model's behavior in the same extent. And that raises the risk of hallucinations, unless the AI is properly guided. And this is why Statista Connect is ideal for organizations further along in their AI adoption curve. Those with the technical infrastructure and, appetite to embed RAG pipelines into their own ecosystems, and they'll find in Statista Connect a robust, endlessly flexible data backbone. As part of the process, our engineers will work with you to build the best possible implementation of our data into your systems, meeting you exactly where you are. And for those wanting greater flexibility from AI but not at the point of implementing custom AI systems, we've also begun embedding our data into everyday AI tools. For example, Statista will partner with Microsoft to bring our content into Copilot, meaning you can soon combine it with your own data from directly within Microsoft tools like Word, Excel, and Teams. Similarly, Statista data is now available in Canva and will soon be accessible through Perplexity, enhancing these platforms with human-curated, verifiable data. And regardless with where you are on this journey, for the foreseeable future, it's essential that you have access to external data to leverage AI. As we saw, without external data, LLMs have truly concerning accuracy and hallucination rates, after being right less than half the time. Yet it is hard to know which data to trust. AI is a double-edged sword, as the efficiencies it brings is also adding fuel to the fire of online disinformation. Statista's trusted dataset takes the uncertainty out of AI adoption by providing you access to a curated collection of verified facts that can be coupled with AI systems. And we now have the range of products needed to meet you where you are on your AI journey, empowering you to navigate these uncertain times on your own terms.
So thank you so much, everyone, for joining us today. For those of you attending this webinar live, we'll be opening up the floor to questions shortly, so don't go anywhere. And if you're watching the recorded version of this webinar via our platform or social media, thank you again for watching. For more expert lead insights across industries, make sure you sign up for future webinars so that you can have access to the data discussed in this webinar and to be part of the live Q&A sessions. And with that, on to the Q&A.
Thank you so much, Nick. Thank you so much, Nina. Hello and welcome. My name is Alexandra. I'm part of the Statista marketing team, and I'm happy to host today's Q&A. I'll start off with the most asked question beforehand. Will we share the slides with you? Yes. We will share the slides with everyone afterwards, most likely tomorrow. We'll also answer all questions we're not able to answer today via mail to everyone afterwards. Nick will take time to go through each question and write down an answer. So, we're not waste any time and jump right into the very first question which we got. This is a very fun question for you, Nick, but I like it and I like to start a little bit spicy. Do LLMs hallucinate more in English than in other languages? And is it even possible to assess?
Oh, honestly, I wish I could answer that question. As one who lives in Germany and speaks terrible German, I wish I had a proper benchmark to answer that. I believe the answer is yes, but that is absolutely something I want to research further before giving a definitive answer to. So, if you'll permit me, I'll get back to that question in the written responses.
Absolutely fair. But let's go to another question which we got. Explicitly for you, Nina. When can we expect to have our model in Copilot, and how would this integration improve the current way of working with Copilot?
So that's a fantastic question. So it should go live in Q3, and now I know Q3 is technically next week, so give us a little bit of time. But it should be through about the middle of Q3. We're still working on it, but from the testing that we've done, it looks really good. And essentially, what it will allow you to do is it'll allow you to ask Statista questions while you're in Word or while you're in, for example, Teams, and kind of get those answers as quickly as possible, so you don't have to go outside of your environment to get to Statista. And I think that's the key of what we're trying to kind of get to here, is that the way that you're doing research is changing and we're trying to adapt to that. So now you have Statista within your Microsoft tools, so you don't have to go back to the Statista website. Makes it a lot easier.
Another question we got, which is again a little bit tricky, but maybe we can answer it. AI outputs and disinformation are some of the risks pointed out. Are there also risks to implementing data subject risks like the right to erasure or the right to rectification, etc.? Are there any solutions to safeguard such rights in the light of such LLM models?
No, I can take this one then. Too early to tell is the extremely simple answer to that. One of the core contradictions, or if one's to be more cynical, points where trust in AI companies is maybe not as great as it should be, is the fact that these companies thrive on data. That's how they train their models. So they would be kind of crazy not to be using the data they're getting to then refine their models. That obviously creates privacy issues, particularly with somewhere with stronger privacy laws like the EU. That's obviously been a political issue over recent times. But on the other hand, we also know that in the American courts recently, because of the use of New York Times material, a US judge actually ordered OpenAI to keep all of their conversation histories. So you've got contradictory things happening here. You've got some regulatory frameworks that are pushing for things like the right to deletion and people having access to their own data. Then you've got some regimes, such as the US courts, pushing for the opposite, with no clarity over whether that applies to people in Europe or what. And then you've got the self-interest of the companies that probably want to be using that information to train. And the truth is, we just don't have those frameworks in place yet. It's too early to tell. I'm not going to hazard a guess as to which of those different forces is going to win out, but it's going to be a very interesting and extremely important battle to watch over the coming months and years to see exactly how this all ends up.
And to kind of add to that, from Statista's perspective, we, for example, don't allow you to train your models based on our data. Now, that doesn't mean you can't, for example, use our API to integrate into a chatbot, but we want to make sure that the models still need to retrieve that data every time. So it's a bit of a difficult conversation here with regards to how that works.
Oh, and also we're not saving, with Research AI, we're not saving the chats and selling that data on or training models or any of that stuff. So you can be sure of that.
Talking about training models, we just have a question which works very well to that context, so I'm just squeezing that in right away. Are you aware of LLM grooming practices, so intentionally feeding wrong information to training data by malicious actors? Do we have evidence whether this is going on in a larger scale at the moment? Can this kind of be proved? Can we see that? Or maybe
I personally haven't heard of the concept, although it would make sense people are trying to do that. But for that to actually operate, it would require some form of very clear feedback mechanism between the models and the information that's being inputted in. Now, my understanding is that a lot of the context that's saved to make something like ChatGPT be more personalized is related to your specific account. It's not actually feeding back into the model for everyone. Now, they do updates that might change the character of the model for everyone. And as we just touched on, there might be some connection between the data that's being stored from conversations and that feeding back into these updates. But I don't believe that you can actually have this direct feedback system where if you keep telling it something that's wrong, that's going to cause a ripple-on effect for everybody. Of course, you can fine-tune models, but that's a much more laborious process, and it's creating an individual model, basically. So I do want to look into that a little bit deeper before saying 100% no, I don't think that's a risk. But based on what I do know, I don't think that's a risk at scale when it comes to one person over here can affect a model that touches billions of people.
But that's also where looking at the sources is extremely important, right?
Yep.
So when you know where the information is coming from, you have a little bit more safety there. So with things like Perplexity, for example, you'll always see the sources, ChatGPT as well. You can see the source links at the bottom. So I would always recommend to check those. I know it's laborious to check every single one, but still looking through and being like, okay, where is this data coming from helps.
I mean, to be honest, that's one of the dirty little secrets about using AI for research. By the time you verify every single source, sometimes you've taken just as much time and put just as much effort in as you would have if you started it yourself. So,
Yeah.
Double-edged sword again.
You literally just answered the next question I was about to ask, which says, is the sourcing of information that Perplexity provides in its outputs reliable? So basically, no, not 100%. Check your sources.
Exactly. Not 100%, but that's why, for example, we've partnered with Perplexity, right? So now you'll be able to see, for example, that a lot of it will come from Statista in Q3. But that's kind of where it comes from. And companies like this also, they have an interest in making sure that their sources are verifiable as well and that they're good sources, because you won't go back to using Perplexity, for example, or another tool if their sources aren't accurate. So they have this interest as well. So it's all still kind of in the best interest of everyone to look at the sourcing.
We're running slightly in overtime, but I'm just going to squeeze in one last question, which I really like because it's a question for everyone. Can you provide examples on how a general user can generate prompts to reduce hallucinations? Just some set general best practices? Any way what you can do? Besides fact checking.
Well, I mean, that's an extremely difficult question to answer because one of the big issues with AIs is they don't know if they're right or wrong. So for you to understand whether there's a hallucination in the output, that's something you kind of need to verify yourself. Like there's not really a way around that. A limitation of AI is that they just simply do not have the ability to know if something's right or wrong. So there are ways you can write prompts in certain limited scenarios that's going to reduce hallucinations, but it may not capture them all. Now, one thing I've had that worked extremely well for me, so I built some sort of customized content generation things for my sales enablement work. And what we found to work extremely well, apart from using a templated output, that really, really helped, was also doing a fact-checking pass. But rather than getting the LLM to look at the content it had produced, do a second pass and go, is this accurate, checking it against the source, checking it against internal memory, and then saying yes or no, what we actually got it to do was to print out a list of the individual facts and then whether it could verify those facts. And that was actually a far better way to do it because LLMs are effectively statistical pattern matching. And so it might have seen the same figure, but rounded into a different number. So say 5.9 in one place and 6 in another, and then seen a difference there and gone, oh, this is a hallucination with that, because it doesn't have that knowledge to know it's actually the same figure. So by printing out those potential hallucinations and then having a human fact check them, that's worked extremely well in my workflow. But that may not be applicable for other particular cases. So that's just one example of the type of thing you can do. But realistically, I think you need to make sure you've got some sort of benchmark where you can test is there hallucinations, which again goes back to you need trusted sources.
Yeah.
And also keeping a human in the loop as much as possible to be able to, you might be able to automate the process of putting those two facts together, but having a human there to make that final call is extremely important if you need that word to be 100% accurate.
With that being said, we're sadly coming to an end. Thank you so much for joining our webinar today. Data on Stage is part of a regular series, so check out our webinar hub at statista.com. Link is in the chat right now to stay updated for our next webinar, and we hope to really see you soon again. Thank you so much, Nick. Thank you so much, Nina. Thank you, everyone, and have a good day.